Hello guys, this is Anirudh here and welcome to yet another video on the Finance with Python series. This is going to be the third video in the series and we are going to be looking at some basic syntax of Python and some pointers to keep in mind about Python. So let's just get started with data types. We are going to be covering a lot of sub-components starting with variables, data types, logical statements, for loops, while loops, how to write a function. The first component that we are going to look at is a variable. So what is a variable? A variable is a placeholder for information you want to store in Python and which you would like to recall later on during the coding process when you need to complete a certain action. So technically the variable acts as an address for where the data is stored in memory. So let's just define a variable item. Let's say it's Apple. You can define another variable item and say banana. Now both of these are completely different variables because Python is case sensitive. So the capitalist I consists of a different variable. Next, let's look at the different data types that Python supports. So Python broadly has numbers. So numbers can be categorized into integers and floats. So integers are, for example, 1, 2, 3, and floats are 1.1, 2.3, minus zero point 0.2, and so on. The next one is strings. Strings are placeholders that are used for text data, and you can manipulate them easily. The third data type that Python supports is lists. So lists are useful for storing a collection of items, such as transaction records, and so on. So let me just show you an example. Count equal to 1. So this is an integer, so we can just say type of count. Okay, it's taking some time to load. Int. So now let me define it as 1.0 and it will return as float. Yeah. And now these are strings. So let's just say type of item str. So str is the abbreviation for string. The next one, the next data type is list. So let's just say L1 equal to, let's say a list of transactions, 1000 minus 2000, 3000, 5000. Now let's say type of L1. List. So L1 is a list. It is useful for storing a collection of items. So what is this green highlighted thing on here? So that is called a comment. So in Python, when you don't want certain lines of code to run, you comment it out basically. So in Python, putting a hash just next to the sentence, typing a hash at the beginning of the sentence completely comments out the line and the line doesn't get executed when the code is running. So on to the next part, which is mathematical operations. So there are a lot of mathematical operations like addition, subtraction, multiplication, division, and so on. So let me just give you like a small, so let me just give you a small summary of all these basic mathematical operations. So you can print A plus B. So these are very basic mathematical operations. You can add, subtract, multiply, and divide numbers. So the next three arithmetic operations are float division, modulus operation, and the exponentiation. So what is float division? So let's say A is 10, B is 3 as taken above. So if you do A slash slash B. So if you give just one slash, then it is normal division. If you have given two slashes, then it's floor division. So yes, as expected, when you do a floor division for 10 and 3, you get 3 as the answer. So floor division, you get 3 as the answer because floor division is an operator that rounds the result down to the nearest whole number or integer, which is less than or equal to the normal division result. So the normal division result was 3.335 and it rounds it down to the nearest whole number or integer, which is less than or equal to the normal division result. And hence it's 3. Now, if you print b slash a, which is 3 by 10, which is 0.3, but when you put in, just keep in mind that when you print b floor division a, you get 0. Why? Because 0.3 rounds off to 0, and hence you get the answer is 0. The next one we're going to look at is modulus operator. So with the same example, we can print a, and now the symbol that is used for the modulus operator is the percentage. So what modulus does is it returns the remainder of a division. So when you divide 10 by 3, you get a remainder as 1. So a modulo b gives 1. Yeah. Now suppose in this case a is greater than b, so you can get a modulo from it. What if you did b modulo a? You get 3. You get the modulus as 3 because when you divide 3 by 10, 3 is less than 10, hence 10 cannot divide 3, and the remainder just remains 3. So now the next arithmetic operation is exponentiation. So for exponentiation, you use 2 stars. Instead of a 1 star for multiplication, you use 2 stars together. So a star star, which is 10 to the power 3, which is 1000. Now let's look at some logical statements, if else statements. So if else statements are called as logical statements, and now let's just have a look at them. So now let's just say have a scenario where now let's just have a scenario where people above 18 are considered as adults and people below 18 are considered as children. So let's say age equal to 25. So it's obviously going to be adult. Now, if you want to take user input every time you run this for age, then you can just say age equal to, you take user input and it is of type integer. So you say input, okay? And within these braces, you can give this sort of precursor to the input that you're giving so that you can explain to the users what kind of input it is. So you can say enter the age. So when you give this sort of precursor, the users know what they should enter and it's displayed in the command line. So yes, just like this. So now if I give 17, child. Yeah, this was an example of a logical statement. Now let's look at loops. What is the purpose of loops? So looping essentially means repeating something over and over until a particular condition is satisfied. And you have two types of loops in Python. A for loop executes a group of statements as long as the condition is satisfied. And it's the same with while loop. So let's say you want to print hello 3 times. Instead of printing say a equal to hello. Now you want to print hello 3 times, so you will print a, print a, print a. Now, this is a very cumbersome process and it's just not that efficient. So what you do is you have a for loop for I in range 3, print a. So here, what you do is you loop. So I is a variable. So when you say for I in range 3, this line initializes a loop that will iterate 3 times. So every loop by default starts from 0 and it goes on until the value 2. So 3 is the upper value over here, and the counter I can be less than or equal to 2 only. It cannot become 3. So I takes the values 0, 1, and 2. So when I is equal to 0, it prints hello once. When I is equal to 1, it prints hello. And when I is equal to 2, it prints hello again. So let's just comment this out and let's check the output. Hello, hello, hello. So we can also add the I over here just to see. So str of I, what are you doing with str of I? So we know that I is a variable which takes integer values. So if you want to convert this integer to a string value, you just say string of I. So 1 or 0 is an integer initially, but when you say string of I, it becomes 1 but enclosed in quotes, which is a string. So let me print this. Hello 0, hello 1, hello 2. So let's take a sample problem just to illustrate how the while loop works. So let's say you want to accumulate a total sum of 1,000 rupees. So you store that in a variable called total underscore sum. And let's say you are able to save about 100 rupees every month after expenses. And let's say the amount that you are able to save increases by 5% every month. So 0.05. So now you want to know how many months it would take you to reach the total sum of 1,000. So in this case, you can use a while loop. So let's say right now the total amount that you've saved is 0. So you want to run this loop till the amount that you've saved is greater than or equal to the total sum. So while you run the loop, so while total underscore sum is greater than total saved, you run the loop. And so after every month, you increase by 5%. Total underscore saved. Yes. So I've just typed up the code for this small question. So what you do is every month you increase the saving by 5%. And every month you add that saving into the total saved. So after the first month, total saved is initially 0. And after the first month, it becomes 100. And the amount that you are going to save on the second month is going to be 105 because you are increasing the amount by 5%, the saving amount by 5%. So it's going to be 105. And now it will loop again. 105 is obviously less than 1,000. So it loops again. And you again go back, add the saving to the total underscore save and increase the saving for the next month. So now if you want to calculate how many months this will take, let's just use another variable called months. Initialize it to 0. When you add savings to the total underscore save, it means a month has passed. So you can say month plus equal to 1. So month gets incremented by 1. So now you can print total saved and months. Let's just run this. So by the end of the 9th month, you can save 1,102. And so you would need 9 months to save this amount. So the next component that we're going to be looking at is functions. So functions are usable blocks of code that are designed to perform a specific task. So they help to break down a very complex problem into very small manageable pieces, which improves code readability, reusability. In finance, especially functions can be very helpful in automating certain financial calculations. So now this is just a small example to calculate the monthly payment of a loan. And this is an example to showcase the use of a function. So the monthly rate is given by the annual rate divided by 12. So we have been given that 5% is the annual rate, which is 0.05 for 1 year. And converting that to per month, it is going to be 0.05 divided by 12. And the total number of installments and payments that we are going to be doing is equal to 12 into the number of years, which is 15 into 12, which is about 180. And so we can calculate the monthly payment using this formula. So right now you don't have to understand how or where this formula came from. And right now we are just trying to understand how a function is useful. So these calculations are very frequently done. And if you want to automate such tasks, you just use a function. And this is the framework of a function. So def here tells our Python code that this is a function, and calculate underscore payment under monthly underscore payment is the name of the function. And in the brackets, you've been given three variables: principal, annual rate, and term underscore years. So these three are called as the parameter that a function accepts. So these parameters are given different values, and using these values, it returns a monthly payment. So that's what this does. So it's reusable in the sense that different combination of these values gives you a monthly payment. So instead of trying to calculate it every single time using a different set of values, automate the whole task by giving it a framework. So inside the function, you do certain calculations. These are very basic math calculations. And after that, you need to give a certain output back. And that is given using the return statement. So what the return statement does is, this is the line for termination of the function. And you had called, and here you're calling the function and passing it some parameters. And the parameters have been given over here. So you're using a variable called monthly underscore payment, calling the function calculate underscore monthly underscore payment, and giving it these three parameters. So when you give these three parameters, it goes to this line, calculates all these variables, and returns the monthly payment. And the monthly underscore payment variable gets the value of this, and you can print the monthly payment. So this was just an introduction to Python programming with some basic math operations, for loops, while loops, logical statements, and how to write functions. And there are a ton of resources out there if you want to learn the inner workings of this. But for financial calculations, this much level of understanding is more than enough. And we'll be learning a lot more of these intricacies as we go along the series. Thanks for watching.